This is going to be the last video of this mini unit. It is about roots of a quadratic function. So first of all, let's define the word roots in the context of a quadratic function. The roots are the place or places where the parabola crosses the x-axis, or in other words, when y equals 0. So for example, in this graph, we have two roots. We have the roots here and here. These are the two places when the parabola crosses the x-axis here, and also when the y value is 0. So then to answer these questions about this graph, how many roots does this graph have? This graph has 2. And what are the roots? We're going to say the two coordinates of this point, of these points. So the first one is at 1, 0, and the other one is at 3, 0. We also call these two places the x-intercepts, the places where the graph crosses the x-axis. But when we are looking at quadratic functions, the x-intercepts have a special name, roots. These roots can also be found by just looking at the equation. This equation here is the equation for this parabola graphed, and we could find these two same points just with some algebra without even looking at the graphs. So we're going to use the two methods and compare to hopefully get the same results. What we're doing is the roots are when the y equals 0. So what we can do is we can substitute the y value to be 0. And then this becomes an equation just like we were solving before during our factoring unit. So we're going to solve this, and in order to solve this, since it's a quadratic function, it has an x squared, we need to factor this first. So there's nothing in common, and so then I look to see next to the x squared, do we have a 1 or a different number? And in this case we have a 1, an invisible one. So in order to factor this, I'm going to see what multiplies to +3 and adds to -4. And then I will fill it in to these spaces here. And let's see, 3 times 1 is 3, and they add to 4, but in order to add to -4, I'll need to make them both negative, -1 and -3. So then we solve to see when this equals 0. So either this one could equal 0, so x is 1 when y is 0, or this one could equal 0. So in this case, x equals 3. And we can see it is the same results we got up here. When y is 0, x could be 1 or x could be 3. Next up, we have this parabola for the equation y equals x squared minus 2x plus 1. So first, how many roots does this graph have? In this case, the graph only has one root. It only crosses the x-axis at one point, right here. So there is only one root. And what are the roots, or in this case, just the one root? 1, 0. Then next up, we can confirm this by factoring. So again, there's no common factor. The number next to the x squared is a 1. So we'll factor by looking to see what multiplies to +1, adds to -2. And fill it in here. So in this case, it would be -1, -1. -1 times -1 is +1. -1 plus -1 is -2. So we want to see when y equals 0. So I'll change this to be 0 and then solve the equation. So either this parentheses could be equal to 0, or this parentheses could be equal to 0. And when we solve, we see that we get the same answer. So that's why it proves that this is our only root. We don't have two separate x values. It's the same thing. the only possibility that x could be is 1. So that is why we have one root for this parabola and this equation for the parabola. The last parabola is this one for the equation y equals x squared minus 2x plus 3. So first, how many roots does this graph have? So we're looking for how many times does the parabola cross this x-axis. So here's the x-axis. Here's the parabola up here. This parabola, it opens up, so it has a minimum. It's never going to get lower than this point right here, because in this direction it keeps going up forever, and this direction it keeps going up forever. So it's never going to be any lower, and that means it's never going to touch the x-axis. It's always going to be hovering above it. So in this case, there are no roots. This parabola never crosses the x-axis down here. So how many roots does this graph have? 0. What are the roots? No roots. We can confirm this as well with factoring. So in the equation, we're looking to see when y equals 0. So then we solve this by factoring. So there's no common factors here. The number next to the x squared is a 1. So I will factor this by seeing what multiplies to positive 3 and what adds to negative 2. So numbers that multiply to positive 3 would be 1 times 3, 3 times 1, negative 1 times negative 3, negative 3 times negative 1. Those are the only multiplication problems that would multiply to equal positive 3. And looking at each one of these, none of them add to negative 2. This would be 4, 4, negative 4, negative 4 when we add them. So this is not possible to be factored. It's a prime polynomial. So in this case, since we cannot get the multiplication problem that would equal this by factoring, it won't equal 0. It won't be something times something to equal 0. So it's not possible for this polynomial to equal 0. Anything that we put in here for x, we're going to add 3 at the end. So it's not going to get us an answer of 0, and that means that this parabola will never have a y value of 0. It will never be along the x-axis. So this work shows why there's no roots in this graph. And that's all for the notes on this day's practice. So let me know if you have any questions.